So homo 11.2, homogeneity, it means same quality. So now we're going to be testing data sets to see if they have the same quality. Let's look at our first example. Here's number 1 on 11.2, homogeneity. Do men and women select different breakfasts? What do you think? The breakfasts ordered by randomly selected men and women at a popular breakfast place are shown below. So for the men, 90 went with the French toast. 48 went with the pancakes. 93 with the waffles. 85 with the omelets. For the women, 91 went with the French toast, pretty similar to the men. 78, though, went with pancakes. That's a lot more than the men that grabbed pancakes. 109 went for the waffles. That's pretty close to the men. And only 58 went for the omelet, much less than the men. All right. So, do men and women choose different things? This is one of those, hotels where they make your breakfast to order. I love staying in those hotels. I only do that about once every couple of years at some soccer tournament usually. But it's wonderful. I always get the omelet when they make it. I always want the omelet. So anyway, so are men and women different here?
Yes.
What do you think? How about we just discuss that for a second? Are men and women ordering different breakfast things here? Just looking at those numbers. Now, on the one hand, you might be going, well, is that like a trick question? Yes. 58 is not the same as 85, and same thing with the other numbers. Of course they're different.
Yes.
But then what am I going to say back to that? What have I been saying all semester? Was that just luck? Right? That's the question of the whole semester. Of course the numbers aren't exactly the same, but couldn't that have just happened by luck? Maybe men and women have the exact same desires for what they want for breakfast. And this little group of men and women we grabbed, we just happened to get a lucky group of men and women that ended up not coming out the same. Maybe that was just luck. Maybe men and women really have the exact same breakfast desires. And this little sample not coming out the same was just because of luck. How do we know? And the answer is, we need to get our hands on a p-value, don't we? Because the p-value tells you the probability that would happen by luck. And so if it's super low, we don't think it happened by luck anymore. We think something caused it, meaning there's really a difference in the desires of men and women for breakfast. Or if there's a good chance of luck, we think, it could have just been luck. Men and women have the same desires for breakfast. Right? See how that's all semester long? That's what we're always doing, right? Of course they're different, but are they different enough to where we don't believe it was luck anymore? That's the whole question. All right, so how are we going to do it? Exam for notes. Test. Now, see how it says it's number 11 here. Test for independence. Add to it / homogeneity. Can you spell homogeneity? That will be on the next exam. I'm kidding. I'm joking. Homogeneity. There'll be an oral component too. You need to be able to say homogeneity. I'm still joking. All right. So test for independence / home. It's the same thing. Really, this is 11.2. This is going to be what we do on next week on Monday, 11.3. They're going to be like identical. 11.2 and 11.3 are really not different. You're just measuring something slightly different, but it's all the same button pushes and same HO and H1. So really this number 11 is a test for both independence, which we'll do on Monday, and homogeneity, which we're doing right now. They're really the same thing. So HO, row and column variables are independent. Well, we're not doing that right now. We will say, what does homogeneity mean again? Same quality. So we'll say same. And this would be different. Same and different. So in a test for sameness, that's what we're basically saying. We're testing for sameness. Homogeneity is a fancy word for sameness. So in a test for sameness, the HO will always be that they are the same. Equal. Remember how HO is always equal? Now that's the word same. Identical idea. And H1 will be different. But how do we do it? How do we actually do it? Well, we've got to take that and put it, we're not going to do L1 and L2. Yeah, you might think, why aren't we just going to do L1? And that's what I would think. We're actually not, because the fact is there could be more rows there. In other problems, well, let me show you one of them. Well, that's got 2 rows again. So does that. There really are some, I promise. I don't see any. Those have 2 also. You kidding me? They didn't give us any without weren't 2? All right, well, there will be later on Monday. I promise. So anyway, we're not just going to do L1 and L2. What are we going to do? We're going to put it in a matrix in our calculator. We're going to do something else brand new on our calculator. How do we do it? Look back at the notes. Here it says, go to second matrix and get the matrix menu. So second, now do you see where the matrix button is? It's above the x to the minus 1. So left side, 4th one down. Is everybody seeing it? So I'll just go back to the question. You have to hit second and x to the minus 1, which has the word matrix above it, that key. So second matrix, and what that does is it takes you into the matrix menu for entering a matrix. You know, good there? Everybody seeing that? And then, what do I say from there? Then I say, go to edit and hit enter. So move over twice to edit. So go 2 arrows to the right, go to the edit menu and hit enter. So when you do, it'll say, all right, matrix A. It's wanting you to put in the information. The first thing you do is put in the size of the matrix. Now, when we put in the size, right at the top it wants the size, you always go down first and then across. It's down by across. So how many down? We have 2 going down and 4 across, don't we? So make it a 2 by 4 matrix. So hit 2, enter, 4, enter. Every time you put in a number, hit enter afterwards. So 2, enter, 4, enter, and it'll put you into a 2 by 4 matrix. You guys tracking with me? And then put in these 4 numbers right here. Those 4 numbers. Put in 90, going across the top, 90, 48. And hit enter after each one. Good question. Hit enter after each one as you're putting them in. This is one of the most complex things we'll ever do on the calculator. Put all those in to your matrix. Got it in there. And then when you're all done with that, you have to hit second, quit. Because every time it's got it saved. It knows your matrix. Every time you hit enter, it saves it. So that's why I'm saying hit enter each time. And you hit enter the last time, it's got it all saved. Just hit second, quit. Even though we're out of that mode now, it knows it. It's got it. Select the size. Input the matrix, hitting enter after each entry. Hit second and quit. Back on the notes here. And then stat, test, chi-square test. We're almost there. Now just hit the stat button. Test, and this time go down to the chi-squared test. Not the one that says GOF, not goodness of fit. That was the section we just finished. Just the chi-squared test. Hit enter, and it'll say A and B. I'm sure it already says that. Just leave it as it is. It'll say observed, and it says matrix A. Just leave it. You don't need to mess with that at all. Unexpected, it says B, matrix B, that's great, just leave it, just calculate. Hit the calculate and you get your numbers. You getting it? I'm getting a chi-square number that's 12.91. 12.912, and a p-value that is 0.0048. You guys getting that okay? If you go back to the notes, the HO, what is the HO again? Same. We're testing for sameness, right? Homogeneity, sameness versus differentness. So when we come over here, so HO is going to be same. So the distribution of breakfast order for men is not the same. No, same. So HO is same, and not the same is H1. So HO is same. H1 is not the same. It's a test. It's a test for sameness, homogeneity. And then we go on to the next one. The test statistic, that's that chi-squared number. That's 12.912. And then the p-value, as we said, was 0.0048. And then the p-value, 0048. We compare it to the significance level like we always do. What's the significance level? Oh, there it is. 0.10. Significance level, 0.10. Add a couple of zeros to compare them easily. 48 is way below 1,000. P is again low. So HO must again go away. So HO is going to go away. What was HO again? HO was same, and H1 was different. So we cross out HO, right? HO must go, reject that. Different, and that's strong evidence, like always, weak and strong, same thing. So we believe that there's strong evidence that it's different, that men and women really do have different breakfast desires. This didn't happen by just luck. It's just too unlikely that would have happened by luck. What's the chance it would have happened by luck? 0.0048. That's the p-value, huh? Probability that men and women are really the same, and you just happen to get these differences by a lucky sample. No, not a very good chance of that. Very low chance of that. It's much more likely that men and women really have different desires. That we didn't get that by luck. Something was causing that. The men like the omelets more. All right. So, based on this, we should reject the null. The p-value is less than the alpha, the significance. What's the final conclusion? Is there sufficient evidence or not sufficient? Sufficient. They're strong, huh? So get rid of that insufficient one. There is sufficient evidence that the distribution for men is the same. No. Sufficient or for men is not the same. Yep, not the same. There it is. Just like that. And these two are the same every time. It's going to be such an easy test, isn't it? These are just the same every time. Trick is keeping all this straight, all at the same time, huh? We'll practice that. That's why we have those practice exams. So probably the battle on this one's identification more than anything else. Good there? Questions I can answer? We'll try another one. We got time for one more.
We were looking for a keyword, like say we were taking the test.
All right. So let's go. Let's do one more of these, just so you're comfortable with this. Question number 2. Democratic. Let's skip that one. Doesn't look exciting. Number 3. Psychologists testing whether different distribution personality types. Okay. Looks good. We'll do this one. All right. So here's a psychology example. This is number 3. We need Crystal here when we do a psychology. She's a big studying psychology. So psychologists are interested in testing whether there's a difference in the distribution of personality types for business majors and social science majors. So here we go, personality types. So open, conscientious, extrovert, agreeable, neurotic. All right. So there's a bunch of business majors and social science majors, and somebody decided what their personality is. That's probably a little subjective. And put them in different categories. So 92 of the business majors have an open personality. 98 of the social science majors have an open personality, etc., etc. So the question is, HO is same, H1 is different. As far as a key word for how you would tell this. Is there a difference in the distribution of personalities? So that would be what you'd see here. When we go over practice exam day, I'll probably be able to say more to point out the characteristics of the goodness of fit versus a homogeneity test. All right, so HO is same, H1 is different. What are we going to do? Pop that stuff in a matrix, huh? So let's go to our calculator and just pop that. So these are really the same every time. Just go to your calculator, hit second, matrix, and then go over twice to edit. Hit enter, and put in what this is a 2 by what, 5? 2 down by 5 rows across. So put in 2 by 5 for the size, and then put in the numbers up there in that matrix, that 2 by 5 matrix. So after you put them in, after you get those numbers in, you hit second, quit out of that mode, and then you just go to stat, tests, and find the chi-square test. Not the GOF, not the goodness of fit, but the chi-square, which is way down near the bottom. And just calculate. And HO is supposed to be same. Which one is that? Is the same. There it is. HO is same. H1 is different. I don't for some reason I didn't put that on the screen. Or maybe I did. Not the same. There we go. It's not the same. And I got a test statistic, chi-square, 3.0876, so 3.088. You getting that okay? And the p-value, 0.54326, so 33. Hey, that's our first high p-value of the night, isn't it? P-value 0.5433. How does that compare to the significance level? What was the significance level? 0.10. So 0.10, add a couple zeros. Which is the p-value below? No. 5,433 is way above 1,000, right? 0.54 is way above 0.10. So that p-value is high. That means there's a high chance this just happened by luck, right? The fact that the social science majors and the business majors didn't come out exactly the same, there's just a good chance that was luck. They didn't come out all that different. That really could have happened just by random luck, is what it's telling us. So the P is not low, so the HO does not go away. The HO does not go away. So what was the HO again? Same. And the H1 different. And you remember how the evidence went. It's weak evidence and strong evidence. And in this case, the HO is not going to go away. So we're going to keep the HO, cross out the H1, fail to reject the null. Fail to reject the null. Keep the HO, fail to reject it. So we keep the HO, which means we believe what? That they're really the same. The business majors, the social science majors, same personalities. The evidence is weak. The evidence is not strong enough to convince us they're different. There's just too big a chance that then any differences are just from luck. Lucky sample. There's not strong evidence that business and social science majors are truly different personalities. That could have happened by luck, 54% chance you could get those results by random luck even if they were the same. So based on this, we should fail to reject the null. What's our final conclusion? Is there sufficient or insufficient evidence? Insufficient, right? Insufficient. because it's weak evidence, insufficient evidence. So insufficient evidence to conclude that the distribution of is not the same. Is that right? That's exactly right. There's not enough evidence to conclude they're not the same. It's a double negative. Is that making sense? So these aren't too bad. They're really this again. HO every time HO is same and H1 is different. So it's kind of nice. There's no more variation going on with the HO and the H1, which is part of one of the hardest things we always had to deal with, looking for the claim in the HO and the H1. Is that good on that one? The other ones are, I'm sure, the same. Question 4. Do the needs of patients... Oh, this one, they're... What do they... Maybe we better just do the first step on this one. Question 4. Yeah, I guess you got to make your own table. Is that what it is?
Yes.
Do the needs of patients in the emergency room differ for those who come in by car versus ambulance? Some of you all know. You've experienced this and lived this. Is that different? The ones coming in by car or by ambulance? I'm sure they are, aren't they?
Very financially.
All right. Oh, what did you say, financially?
Yeah.
Yes.
Like $8,000.
All right. Of the randomly selected emergency room who came in by car, 51. So here's by car. So we're going to do by car, and then we're going to do by ambulance. So we'll make our own table here. Car and ambulance. And we'll have injury. So 51 had an injury. 60 were sick. 60 were sick. 44 had heart problems. Heart problems. That was for Dafy's group. All right. And 60 had other needs. 60 had other needs. Okay, and then those that came in by ambulance, 47 had an injury. All right, let me make that a little neater. That was it. 51. 47 had an injury. 28 were sick. 45 had heart problems. And 25 had other. Conduct the appropriate hypothesis test. So you know what to do from there, right? HO is same. H1 is different, not the same. And then put the matrix into your calculator and hit the buttons, get a p-value, and away you go. Same thing every time, right? Is this your favorite section yet? All right, so that's make your own table. And number 5, what does number 5 have? Anything special? That's the same thing. Work study, not work study. There's number 5. Just put it in your calculator. Crank it out.